Alright, then we shall begin. How did everyone's weekend go? Good, more or less, I hope. And the homework went okay?
Yeah.
I checked in last night and maybe 30 of you had not done the homework, and then I checked in this morning and that had jumped up, and then I think I got quite a few in like the last 15 minutes, but that's okay. And I'm just trusting you that when you say you did the homework, you actually did the homework. And this one should have been really easy. There were only 3 problems. It should have been not too bad. Okay, tonight you'll have a few more problems to complete before Wednesday. You will also have your first lab meeting today in Bolter 9413. Are you guys familiar with where that is? Okay, so you will go into Bolter. If you go into the main entrance at Bolter, the one, I don't know, there's several entrances to Bolter, but if you go through the central one, you're going to either hang a left or a right, and you'll take the elevator up to the 9th floor. And then you will go out, and you will see it'll be outdoors, but the classroom will be there. Okay, so because when you get to the 9th floor, when you exit the elevator, there will be like a tiny space, and then you'll go outside, and you'll be on what feels like the roof, but there's actually classrooms there. Okay, and that's where it will be. Let me just say a few things about the lab. You will be using software called R and RStudio. They're free open source software. They are very good and powerful programs to do statistical analysis, to do graphing and things of that nature. However, there is a steep learning curve, and in the beginning, especially these first few labs, it will feel very frustrating to do what feels like very simple tasks, okay? Because you interact with your data through a command line interface. You're going to be typing in commands that says basically, I want you to rearrange the columns this way, I want you to rename this, or I want you to do these, and you're going to be typing in these commands. Many of you have probably used Excel at some point in time, and you will be questioning, why do we have to use this when I can do the same thing in Excel a million times faster? And the answer is, well, I guess there's a few reasons, okay? One is that, Excel is designed for an office workspace, not so much for data analysis. A lot of times when you do some kind of data analysis, you want your work to be reproducible, meaning if you give someone else the same data, they can come do a similar analysis and come to the same results. And you want to be able to show people what you've done. With a point-and-click interface such as Excel or other things of that nature, a lot of your things require on dragging things around or manipulating things with the mouse. By having to type everything in, you will essentially have a record of everything you've done. And basically, if you send somebody else the same commands that you've typed in, they can reproduce your work. Like everything that's new, learning something new can be frustrating and awkward, but I would say don't give up, and just, if you will bear with me and stick through this learning of of R, RStudio, and R Markdown. I hope it will not be as terrible as it seems in the beginning. I was trying to think of a similar analogy from life, and I don't know if this applies anymore. I think everybody here still learned first to write with a pen and paper and then learned to type. Is that correct? Is that still a safe assumption? Okay. So the first time you had to type words into a keyboard, it probably felt slow, awkward, and cumbersome. Is that a safe statement to say? Okay. But I would say today, probably most of you would prefer to write a long letter on the keyboard rather than with pen and paper. Okay? So in the same way, many of these things will seem awkward and terrible on R, but in the long run, and that's, I guess that's the point of contention here, is that probably after this class many of you will not face R again, but if you were, I think you will appreciate at least some of the exposure you had to R rather than Excel. And then later on in the course, there's just some things that can't easily be done with Excel that can be done very, very quickly with R. Okay? All right. Anyway, you'll meet Aroma Lynn for the first time, and she's great. She'll guide you through the labs, and that's that. Okay. Any questions? Any issues before we continue on? Okay. Did anyone view the video that I recorded? Yeah, it doesn't matter. Okay. Well, I'll continue recording these. I'll continue posting these, and I'll go over there. Okay. So today we are covering Chapter 3, which is all about displaying, summarizing categorical data. So again, if we are looking at a data set, every row in that data table will be considered a case, or would be considered the who in our data. The different columns of data that we've collected, those are the variables, and those columns contain either categorical data, or categorical variables, or numeric variables. Numeric variables tell us how much or how many, whereas categorical data tells us what type or what kind. So you can imagine collecting a whole bunch of data, and the example that we will use is comes from what is the Titanic data set. Okay, so there was 2,000 some passengers on the Titanic. All right, the Titanic was a large ship, boat, left Europe, headed towards the United States, hit an iceberg and it sank. It actually happened. They made a movie, all of this, okay? Apparently there was some debacle where people thought it was just a movie and didn't realize that it was a real event. But the characters of Jack and Rose were fictional, but the boat actually existed and sank. All right, anyway. So if we could take a passenger list, okay, and so let's say we have Jack, and we kept some information on each of these passengers. We have sex, whether they were first class, second class, etc. So this will be we'll write this class, and then whether this person survived or died. All right, so if we pretended that Jack Dawson was a real character. Has everyone here seen Titanic? Who has not? For shame. Okay. It's an excellent movie. It's very long, and perhaps it is being made fun of for being so cheesy, but if you actually sit through it, it's a good movie, all right? They re-released it in 3D and not a few years ago, and that was quite good also. All right. So Jack was male. He would be a third-class passenger. And, sorry, spoiler, he died at the end of the movie, okay? Even if you know that he died, it's still worth watching. Okay. Rose, on the other hand, female, first-class passenger, survived. And then, you know, you have, I don't know, Violin Man, male. He would be a crew member, and he died. Okay, anyway, so we could imagine a whole, the entire table being filled out how many rows would there be? I'm sorry? The number of passengers, so 2,200 something passengers. How many passengers total are there? Many. 2201 passengers total. Okay. And we can summarize this with a frequency table. And with a frequency table, we would just select one of the variables. So let's say the variable we select, frequency table for the variable class. All right. And so on one side we would have the variable, and over here we would have the frequency. And we would list which category, the different categories. So we have first class, second class, third class, and we have crew members. The frequency would just be a count of how many people, okay? And so we would go through and we would say, how many first class passengers, and we'd find Rose, and we'd find, I don't know, Billy Zane's character, and whoever else. There's a total of 325 first class passengers, 285 second class, 706 third class passengers, and 885 crew members. So quite a large crew. And this would serve as a frequency table. All right, we can add another column to make it a relative frequency table. And a relative frequency table just takes these numbers and turns them into percentages. So the first thing we would have to do would be to add up how many passengers total that we have. So we have a total of 2201 passengers. And then we would say, well, how many of those passengers were first class? So I would just do 325 divided by 2201. And we would see that that's equivalent to 14.77%. And I would do this for all of the different classes. 12.95, 32.08, and 40.21, for a total of what should be 100%. And if it's not exactly 100%, it's because of some rounding issues. Alright, this should be rather straightforward and easy, okay? The key here, though, is that don't be misled by the numbers, okay? So we have frequencies and we have relative frequencies, and we keep track of them with counts or percentages. So if you were to see a summary table like this, and I were to ask, is the underlying variable numeric or categorical, you would have to identify and recognize that this is categorical data, right? Despite the fact that we summarize it using numbers that tell us how many are in each category, the underlying data itself is categorical. Right? And we can, so if we have data like this, we are looking at one categorical variable, we can display it with a bar chart. Okay. And with a bar chart, we would just list off the different categories that we have. Across the horizontal axis and the vertical axis would be the frequency. So my largest is around 900, so 1, 2, 3, 4, 5, 6, 7, 8. And I would just make a column or bar as tall as is appropriate. So 325 in first class, 285 in second class, 706 in third, and 885 crew members. And this would be my bar chart. Okay. Now realize that I could, if I were to divide all of these numbers by, whatever number I change, let's say if I were to just change the scale here. So let's say instead of saying how many passengers were, or how many people were crew members, and we say 185, I could say how many, assuming everybody has 2 legs, I could say how many legs were, would belong to crew members, okay? And then we would just take every single one of these numbers and multiply by 2, okay? And so I could just create another scale over here that says legs or whatever, and in that same essence, I could take every single one of those numbers and divide by 2,201, and over here I would have bars exactly the same height, and it's just that now I would have percentages over here. So this would be 40%, 20%, 10%, and 30%. And this would be equivalent, and so over here I would have relative frequency. So we can make a bar chart for frequency or relative frequency. We could have multiple scales if we wish. Alright, it's bar charts could also be horizontal if I wanted to display the bars this way, equally valid. It doesn't matter. The thing about bar charts is I could also rearrange the columns. Okay, I could rearrange these from the most largest to smallest, so then it would go crew, third, first, then second. I could change the order of these bars in any order I choose, and the information contained in the bar chart would be equally valid and correct. Okay, so maybe not as stylistically pleasing, but correct nonetheless. We also have pie charts, which if you've ever used PowerPoint or some presentation software like that, you are going to be familiar with it. And PowerPoint looks, not PowerPoint, a pie chart would look something like this. Personally, I'm not a huge fan of pie charts. They make sense if you are trying to show, I guess, what percentage of a whole belongs to what category. The problem with pie charts is it's very difficult to distinguish categories with similar percentages if they're not labeled. Okay. If you were to look at this piece and this piece, it would be tough to say which piece is larger, okay, just by looking at a pie chart. Whereas if you look at a bar chart and I say which bar is larger, it's very easy to distinguish. Okay. So pie charts, less preferred, but they do exist, and you should be able to read them. I erased the information, but let me just write the height of these bars over here. So looking at that, would it be reasonable to say that about 72% of people aboard the Titanic were either crew members or third-class passengers? Yes, okay. And so when you have each person belonging to only one category, one and only one category, so a person cannot be classified as both a third-class passenger and a first-class passenger at the same time, it's reasonable to add these different percentages together and say, you know, this percentage is made up of these different categories. On the other hand, we might have percentages that aren't what we would call mutually exclusive. Okay, so over here, each category, each person can only belong to one category. Okay, so the categories are mutually exclusive. We'll see that come up again. Another term for that is disjoint. On the other hand, we can take a look at maybe two variables at the same time, and we would see percentages that aren't necessarily, or categories that aren't necessarily mutually exclusive. Okay. So let's say we looked at the survival and the class. Okay. So if we looked at two categorical variables, we would summarize this with what we would call a two-way table or a contingency table. Okay. I should write AKA. Because they are the same thing. So first class, second class, third class, and crew. Let me actually, well, I'm just going to copy what's in the table here. 118, 178, 212. Alright, and if we were to add all of these up, we have 711 people who survived and 1,490 who died, for a total of 2201, and I could add up each of these columns. And so this shows us, this answers questions such as, how many first-class passengers survived? And your answer would be 203 first-class passengers survived, 122 first-class passengers died, 178 third-class passengers survived, whereas 528 third-class passengers died. Okay, so this again just shows us counts, and we might be curious or interested in what we would call, I guess, the marginal frequencies, and then also the conditional frequencies. So the marginal distributions, okay, would just be looking at the total columns or total rows. So they're considered margins because they're in the margin, I guess. Okay, so the marginal distribution for class would be exactly what we had earlier, okay? So the marginal distribution for class is just these four numbers, which we saw at the very beginning. So if I talk about the marginal distribution for class, it would be the table that you've already created, which says first, second, third, and crew, and it has these same numbers, 325, 285, 706, 885. Okay, that would be the marginal distribution, and we would turn these into percentages, okay? And we've already calculated these out. So if I say, what's the marginal distribution for survival, you would tell me that it's basically these two numbers here, okay? So for marginal for survival, you would just have survive versus died, survived, died, 711, 1490, and then we would turn these into relative frequencies, and 711 divided by 2201 is 32.3%, and on the other side we have 67.7. Okay, for a total of 100%. So that would be the marginal distribution for survival. Fair enough? Okay. If I were to say, if I picked a random person aboard the Titanic when it left, and I asked, what is the probability that at the end of the voyage, this person survived? What would you say? 32.3%. So if I just say, if I pick a random person, what is the probability that this person survived? Person survives or survived, I don't know. So if I picked a random person, what is the probability that this person survived? You would say 32.3%, or I could say probability that someone survived is equal to 0.323. This notation is not yet mentioned in the book, but we will see it plenty of times in the future, so I'm just bringing it up now. I don't think it's incredibly difficult at this point. All right, so these are marginal distributions. Okay, when we look at just the total column, then we have the marginal distribution. We also have the conditional distributions. So I could create the condition that someone be in first class. Okay? So in this case, I'm only looking at a total of how many people? 325 people. So if I create the condition, we are only looking at first class passengers. I'm only looking at 325 people. So essentially, if I look, the only part that information that would be relevant to us would be this portion of the table. And we have 203 passengers who survived, 122 first-class passengers who died. And so the conditional distribution for first-class passengers would be 203 divided by 325, which would be 62.5%. And 122 divided by 325 is 37.5%. Is that fair? Okay. So just very quickly, make the tell me the conditional distribution for third class. Give you guys a few seconds to do that on your own. So you'll probably need a calculator. All right, so what do we have? Condition for third class. Over here I would write survived versus died. 178, these are the counts, 528, and so what are the percentages here? 25.2 and 74.8, great. All right, so what do we notice? If I'm gonna change this. I hope I don't regret erasing this table, but I might. And this eraser is disgusting. So if I were to pick a random person, if I picked a random person in first class, what is the probability that this person survived? 62.5%. Right. And if I picked a random person, I should say random, in third class, what is the probability that this person survived? 25.2%. So does it appear that someone's probability of survival is associated with the type of passenger this person was? Yes, and there seems to be strong evidence suggesting that first-class passengers were much more likely to survive than third-class passengers, okay? And if you saw the movie, they pointed this out, right? They had them all locked up behind that gate, and you know, if that were to happen today, there would be a large lawsuit for the boat sinking, and then there would be a large lawsuit for discrimination, and I don't know. I heard there's some billionaire in Australia trying to build the Titanic 2. This just sounds like, does not sound like a good idea. He's saying it's unsinkable too. All right. Okay, so we would call these conditional probabilities. These would be the conditional distributions. And let me just show you a peek at the notation for this, which we'll cover in fuller detail in a couple weeks here. Okay. So this would be the probability that someone survived, and I would write this vertical bar, which is read as given, that this person was in first class. Over here, this is the probability that someone survived, given that the person was in third class. If survival had nothing to do with the class or type of passenger someone was, how should these numbers appear? They should be the same. If survival had nothing to do with class, then the percentage, if I said this, if I picked a random person in first class, what's the probability that this person survived? That answer should be like 32%, or the overall survival percentage. And then, if the answer over here is 32%, and if I ask this question, if I picked a random person in third class, what's the probability that this person survived? That answer would also be 32%, okay? Because in that case, class and survival have nothing to do with each other, okay? So, let me just write this. Because these two numbers, are not equal, so it appears that class and survival are associated. The two categorical variables, class and survival, appear to be associated because those two numbers are not equal. If they were equal, on the other hand, they were equal, then we would say the two variables do not appear to be associated. for example, probability of survival. If I just picked a random person, I forgot what this number was. If I just picked a person at random, the probability that this person survived is 0.323, and this would be, what's the probability that somebody survived if they were in first class? And that should also be equal to 0.323, and probability of survive given third class should also equal 0.323. If that were the case, then we would say that the variables are not associated. Whether someone is in first class, second class, third class, or a crew member had nothing to do with this person's chances of survival. And there we would have that. Is that good? All right. Okay, so let's say I could create conditional distributions for all of the classes. So I have first, second, third, and crew. Then I have survival, or survived versus died. We've already figured out a couple of these numbers. We said chance that somebody survives in first class was 0.625, and that means we have 0.375 over here, and over here we had 0.252, which means we have 2.748 right there. And if I fill in the rest, I have 0.414, 0.586, guess I could have done that, and 0.240, which means that 0.760. So this would be the conditional distribution based on class. And how can we display this? Well, there's a few ways. One is what we call a segmented bar chart. Okay, with a segmented bar chart, I would have 4 bars, all of them, one for each class. And they would all be the same height. The total height representing 100%. So they would all be 100% in height, but we would draw a dividing line indicating which part survived and which part died. So this would be something like that. Is the construction of this segmented bar chart okay? All right, I see a thumbs up. All right, and so this would allow us to see, without needing to see the numbers themselves, we can see, all right, the probability of survival seems to be different based on the different classes. Whereas crew members and third-class passengers, they seem to have similar rates of survival. We have 25% versus 24%. We would see that in the segmented bar chart. I forgot to write that. This is called the segmented bar chart.
It's 11:45.
Is it 11:45? Okay. Excellent. Okay, so we have a segmented bar chart. Then